This is Unit 12, Electrochemistry, Lesson 6, Electrolytic Cells. How does an electrolytic cell work? The objectives of this lesson: I can identify an electrolytic cell, and I can differentiate between an electrolytic cell and a voltaic cell. So do now. So electrolytic cells are non-spontaneous reactions. There is no flow of electrons to produce current. You need an outside power source to make them run. And this will convert electrical energy into chemical energy. So this is the opposite of a voltaic cell, and this is how we charge our batteries. Electroplating is the process of adding a layer or a plate of metal on the surface of another object. For example, gold-plated jewelry, where we'll take a cheap metal on the inside but then put a layer of gold on the outside, and chrome bumpers, where we make the inside very strong and tough with a strong metal, but it's not very nice looking, and then we'll cover it with chrome, which is a beautiful shiny surface. So the electroplating process, the battery will force electrons to travel to the spoon. So I've got a spoon in here. It's a center core of tough, durable material, but it doesn't look nice. And then what I'll do is I will add electricity, which will cause this silver bar to decrease in mass as electrons flow. And then they'll go into silver ions, which will then plate onto that spoon, which has electrons to attract that positive charge. So because the spoon is negative and that will attract those silver ions, the silver ions will reduce and stick onto the spoon. So the silver bar is the anode. It will lose electrons and it'll eventually disappear. So whatever metal I have, I can do this as long as I have metal. So at the anode, I have silver becoming silver ions and the loss of electron, which will go up through the wire. And then at the spoon, which is the cathode, I have silver ions being attracted by those electrons, which will plate onto it and make a silver solid. So a quick comparison: the voltaic cell will have an anox as the red cat. So I have both oxidation and reduction at the occurring at the same places, and I still have the flow of electrons in the same direction. So these two things are the only thing that's similar about voltaic and electrolytic cells. Otherwise, the differences are that voltaic is spontaneous and electrolytic is non-spontaneous. Voltaic makes electricity, and the electrolytic needs electricity. The voltaic has a salt bridge, and the electrolytic has no salt bridge. It's in the same container. The anode in this case is positive and the cathode is negative. And even though we have the same direction of electricity, the anode is positive and the cathode is negative here. And then in a voltaic, the chemical energy is spontaneously changed to electricity. And in an electrolytic, the electric energy is being changed to chemical energy. So check your understanding. And now you can identify an electrolytic cell, and you can differentiate between an electrolytic cell and a voltaic cell.